Welcome to the second video in the series. In this video, I'm going to show you how to build and test the contact entity. Now on your screen, you'll see the page for assignment 3 on the course website that I built. And if you scroll down the page a little bit, you'll get to this section where I actually itemize the requirements for the contact entity. So you can see that it requires 5 fields: ID, first name, last name, phone, and address, and each of those has their own special requirements. The ID, first name, and last name are all pretty much identical, except the ID must be immutable. The phone number is similar, but it must have exactly 10 digits and only numbers. And the address is similar, but it allows up to 30 characters instead of stopping at 10. Now, in this video, I'm only going to demonstrate the ID, the first name, and the phone number for the sake of time. But you should be able to take what I show you and apply it to complete the rest of these. So with that, I want you to open up the project in Eclipse, and you should see that there is a source test Java directory, a source main Java directory. Each of those in turn has the org SNU CS320 package. All right, so we always want the test and the main folders to mirror each other. Package structure should mirror each other. So you see the package is the same here as it is here. And I want you to delete the starter and starter test files. We don't need those. So let's go ahead and remove those. And you're going to have 2 more assignments following this. And so to keep everything organized, I would like to create a nested package in each of these directories. So we'll right click on the org SNU CS320 in the source main Java directory, and we'll go down to new, choose package, and we're going to add a package called contact that's nested there. And if your structure looks a little different, for example, if you see org SNU CS320 and then under that you see org SNU CS320 contact, go up to the vertical ellipsis, go down to package presentation, and make sure you have hierarchical selected. And that will actually collapse these packages into each other the way you would expect a folder structure to appear. And then we're going to create the same exact package in the source test Java directory. So again, new package and then name it contact. And to get started, we're going to create our first code file. We'll create it in source main Java. So right click on that package, choose new class, and we're going to name this contact. And the contact class has 5 fields. So I'm going to create all 5 of these, but as I said, we're only going to focus on testing 3 of them. So the first field is going to be ID. The next field is going to be first name. And then you have last name. And then you have phone. And you have address. And you can't do a lot with these fields until you have a constructor so that you can actually create a new contact and set these fields. So let's go down a couple of lines and then right click in Eclipse and go down to source, choose generate constructor from fields. Make sure you have all 5 selected and choose generate. And you get a nice constructor there. And now we have enough to actually start testing. So we can actually test the constructor out. Let's go over to your source test Java, right click on the package we created there, choose new class, and we're going to call this ContactTest. JUnit is a little bit particular about how names should be. So the pattern is to take the name of the class you're testing and add the word test onto the end of it. Choose finish, and we're going to test our first class. We're going to test that constructor. This will be our very first test we write. And I'm going to name this test successful creation. And then you see a red underline under the word test here. So we'll hover over that and make sure you import the version that has the word Jupyter in the package name. And that does tell JUnit that this method should be executed and the results of the test in it should be recorded. And inside of that, the first thing we're going to do is we're actually going to create a new contact. And I'm just going to copy some code I already have written because it takes, to make sure this video is as short as I can make it. You can take the time, you can pause the video and type this yourself if you wish. But you see, all I do is I create a new contact with valid values for each of the arguments passed into it. And then I'm going to make an assertion on that. So we'll say assert that contact. And you'll notice this red underline appears under assert that. I have configured Eclipse to actually allow or actually suggest static imports. By default, your Eclipse will not suggest static imports, so you will need to type this by hand. There's the import statement you need to type by hand at the top of your file. Pause the video now and do that. I'll also show this in the lower thirds for you. But I did import that, so now we can make some assertions. And one of my favorite assertions is has field or property with value. And what this allows me to do is say, hey, JUnit, I expect that the object I'm making an assertion on, in this case our contact, should have a field named ID and it should have a value of 1. And I'm going to copy this several times. And of course we'll test first name, we'll test last name, we'll test phone, and we'll test address. And then I can just copy these values down there because that is what we expect. And what this is doing is it's actually making sure that when we pass these values into our constructor, the constructor properly set the values in the object and they were stored correctly. And so now we have our first test and we can run that. So right click on the test name or the method name, go down to run as and choose JUnit. And you should get a green bar here. Very good. Now, the next thing we want to do is we want to create some getters and setters on our contact object so we can manipulate these values, because if you recall in the requirements, while the ID field is immutable, none of the rest of the fields are. So they should be able to be set after you have created this object. And of course, you want getters for all 5 fields because you want to be able to find out what those values are after you create the object. The easiest way to do that is to right click in the contact class, go down to source, generate getters and setters, select all, and then make sure you unselect set ID because that is an immutable field, so we don't want to be able to change that. And you see it auto-generates those getters and setters for us. Very good. Now at this point, we are doing test-driven development, so we have enough code in our contact class to go write some more tests. And of course, we expect these tests to fail until we finish coding the class, but that's the way it works with test-driven development. So the first test the second test we're going to make is one called test successful setters. So we'll do that. Test successful setters. And this test is just going to test that the setters work and that after we call them, the values on the object are updated correctly. So what we'll do is we'll copy this object we created and then we will set some fields. So we'll say contact.set. See, we can't set ID, it's immutable. So we'll say contact.set first name. We'll set the first name to Bob. And of course, as I mentioned, I'm not going to be doing all of the fields for the sake of time, so we'll just skip to phone. And I'll set the phone number to something different. So in this case, maybe 999-1111, and then 2222. And next, we want to make some assertions on that. So let's copy the assert that. And all we want to do is assert that these new values are being stored properly. So we'll assert that first name is now Bob and that phone is now the new phone number. And of course, once you, I expect you to go ahead and test all of the setters, but I'm going to omit the rest of them for brevity. So let's run this test and see if it works. So we'll right click, run as, JUnit test, and you can see that it does pass. Very good. And now we can write another test, and we're going to name this one test failed creation. So now we're testing a failure path, right? That's important. We don't only want to test the way things ought to work, we want to test that the program copes with and handles the way things should not work as we expect it to. Now, there are many different ways that the contact should fail to be created. For example, if you omit the ID, pass in null or blank or anything like that, if first name, last name, or any of the other fields are too long, it should fail. So there are a lot of different failure scenarios. So in this case, let's just write a few of these. Now we're going to do ID, and I'm going to copy some code over here for the sake of time, but I will walk you through starting this. Because there are so many different possible test cases, we're going to use something called a parameterized test. Okay, so, and then you'll hover over that and choose import parameterized test. Make sure it comes from Jupyter. And then this parameterized test, what it should do is it should receive values for the different fields. So I'm only going to do the ID, the first name, and the phone. I expect you to do all 5 fields, but it should be pretty easy to figure out the rest. And then you have to get those values from somewhere. So JUnit is going to run this over and over and over, and every time it runs, it's going to pass in the next set of values. It gets those sets of values from one of several different kinds of sources. In this case, we're going to use something called a CSV source. So make sure you import that as well. And then the CSV source takes an array, and this is an array of strings. So you can have multiple strings, and within each string, it expects a CSV formatted series of values. And so, as I mentioned, I'm going to just copy in some values I've already written over here. This one, these first 3 values test the ID. So what you can see here is that it takes an empty string, and then first, last, phone, and address. And at this point, we don't really have any error messages, so I'm going to omit this. I will add those in a little bit later. And you can see that in the second one, it tests for a null ID, so this ID just has nothing with a comma. And then in the last one, it tests an ID that's too long. So all 3 of these should fail to create. Now let's make sure these values are being passed in correctly. So we can do that by, we can say, all right, print out the ID, okay, and print out the first name, and print out the phone. And of course, we're only doing the first name, the phone, and the ID. So we'll get rid of these other values I have. But again, I expect you to test all 5 fields. So your code should look more like what I had before I'm removing these extra values than what it does now. And then we have ID, first name, last, and then phone. We're not going to test the address. Get rid of that. And so what this is going to do is it's going to have JUnit run through these first 3 values, and then they'll be passed in. And if everything works correctly, it should print them out to the terminal. So let's right-click on this and choose Run As, JUnit Test. And you can see down here it does exactly what I said. The first one's just a blank string because we use single quotes around nothing. The second one is null because it's nothing with a comma. And the third one is the very long ID number. Now, we also want to test first name, so I'm going to copy in some more code, and we will test the first name. Again, I'm going to remove everything but the ID, the first name, and the phone. So let's get rid of that. And so now we have the first name, and then finally we want to test the phone, so I'm going to copy these in as well. Now, the phone has multiple ways it could fail because it has a few more validations than base. And let's print these out and make sure it looks the way we expect it to. Okay, so everything is there the way we'd expect it to be. All right, now we want to make an assertion on this, but we have to make a decision at this point. So the decision we have to make is, how do we indicate that the construction of the object failed? Because you can't just return nothing, right? The constructor must return something, or it must throw an exception. And so the only way we can make this really work and testable is if we throw an exception from the constructor. So in our test, what we want to do is we want to say assert that thrown by. This is another JUnit assertion that we can import. Again, this is a static import, so you'll need to hand type this import statement into your code. I'll scroll up. You can see it here. And I'll put this in the lower thirds for you as well, so it'll be on the screen. And we'll say assert that thrown by. And because we can't throw the assertion right when this code's evaluated, otherwise the test would never run, we have to pass this an anonymous method called a lambda. And that method will be called by JUnit after it evaluates the test. So in the lambda is where we will construct the new contact object. And we're going to pass in the ID, the first name. We'll pass in just a fictitious last name. In your case, you should have values for all 5 fields in your CSV source, and so you should be passing in the variable last name rather than hard coding it the way I am. And then, of course, phone, and then I'll pass in a fictitious address. In your case, you should be accepting the address from the method parameters, because you will provide an address up here in your CSV source. And so now we want to go down to the next line, and we want to say dot is not null, and we'll make some more assertions on this later, but all we're doing is we're saying that this should throw an exception and the exception should not be null. So essentially we are asserting that an exception is thrown. Pretty simple, right? And so let's run this test. We do expect it to fail, because if you look at our code right now, we're not throwing an exception. So we'll go back and we'll run it, right click on the test method, run as, and JUnit test, and you see that all 12 test cases fail. Now we need to go back here and we need to actually make some assertions on this code on the variables coming in and throw an exception if those fail. So let's look back at our requirements for ID. It cannot be blank or null. It cannot be more than 10 characters in length, and it cannot be changed. So we'll say if ID is null, or ID dot length is less than 1, or ID dot the length is greater than 10. All right, so that covers all 3 of those. Not blank or null, no more than 10 characters in length. So this is not null, this is not blank, no more than 10 characters in length. And now we'll throw an exception. We'll throw new exception. ID is bad. Pretty straightforward. And when we throw an exception, we're using what's called a checked exception. Java has 2 types of exceptions. One is called checked, one is called unchecked. A checked exception is one that the developer who wrote the checked exception expects other developers to handle. In other words, it is expected that the program could possibly recover from this issue. An unchecked exception is one where the programmer is not expected to be able to recover from it. For instance, if we were writing a command line interface application and it takes certain required arguments, and somebody typed in the terminal that command but neglected to enter those arguments, the program really has nothing it can do at that point. That would be a case where you might use an unchecked exception. In this case, we do want the exception to be checked, right? So, for example, this might be used in a GUI, somebody's contact book, and when the exception is thrown, we may display an error to the user saying, hey, you need to go enter this field and we'll try again. So that would be a recoverable situation. So we're going to make this a checked exception. And a checked exception is any exception in Java that extends this class, the exception class. An unchecked exception is any exception that extends another class called a runtime exception. The difference is if we do a checked exception, we either have to surround it with a try-catch or add a throws clause to the method that it is in. In this case, we're going to add the throws clause. If we had used a runtime exception, an unchecked exception here, we wouldn't have to do this. So let's save that, and let's go see if we get any of these tests to pass now. So we'll go back, and you'll notice that now that we have a checked exception in the constructor, we do have to declare that everywhere that constructor is used. So I'm going to add that throws clause to all of our test methods now. The only exception is down here. We don't have to do that because the cert that thrown by already handles that for us. So let's rerun the test failed creation. And you'll notice that 3 of our tests pass. So that's pretty cool, right? Now, one situation that we didn't test is, what if the ID has a space in it? That would also be considered a blank ID, right? So let's try that. Oops, that one fails. So that's a good example of where we need to go in here and say, and trim it, so we get rid of the blank spaces. And now we can try again, and that one passes. Additionally, we may want to do that with these others. So let's add a space here in the single quotes, a space here in the single quotes. And I'll just get rid of these, that first one. So I think that's a better test. Now you notice that we still have these other failing tests, so we do need to test first name. So let's do that. And what we'll do is we'll just copy the variable name up here. Can't be null, it can't be less than 1, and it can't be greater than 10. All of those hold true for first name as well. And then we also want to test the phone number with one big difference, right? It can only have numeric characters. So let's go ahead and replace these variables quickly. And then we'll say or phone.matches. So we're going to compare it to a regex. And in this regex, we're going to say if it has any characters before, 0 more characters followed by a non-digit. So that big D means anything other than numbers. And that could be followed by more characters. In other words, we're saying if this string contains anything that's not a digit, a 0 to 9 digit, it matches this regular expression, and therefore it throws an exception. So let's run our test again, and they all pass. So we're on the right track here. Now, at this point, I have to point out that while we are validating the information that is entered when the contact is initially created, okay, we need to also test our setters because we don't want this to be updated after the fact with bad data. So let's go down to our test and we'll add a new test called, we'll just make it a test. We'll add a new test called test setting first name. And it will accept the first name. It's going to be a parameterized test. So let's fix that. And the CSV source will be several values. The first one will be empty first name. We'll have a first name with just spaces. In fact, we'll make, and then we'll have, let's see, then we will have a first name that is too long. All right, and I should do it. So here, remember here we have to surround that white space with single quotes or it's interpreted as null. And so we're going to pass in those 3 values here, and then what we want to do is we want to create a good contact object to start off with, and with each of these we want to verify that an exception is thrown. So let's grab this up here. So assert that thrown by, and what we're going to do is we're going to just, instead of creating a new contact in the lambda, we're going to set the first name field in the lambda to the first name passed in. And of course we have this constructor, so we have to declare that exception might be thrown. And let's try this. Let's see what happens. It fails. So record at index 1 contains invalid ceases. Okay, so what we need to do is we probably just need to add some commas. There we go. Let's try this one more time. There we go. So now you see null, empty string, and then too long. So let's go back here. We need to fix that. To fix that, we can copy this same check into the setter. Now, interestingly, just like the constructor, we now have to declare this exception. Let's rerun our test. They all pass. Very cool. But what you'll notice at this point is that we are now doing something that's usually considered bad practice, and that is duplicating code. So before we address that, let's go ahead and fix up the phone field as well. So we'll just copy that, put it down here, and set phone. Again, we have to declare that exception. And so now we've got these same tests in the constructor and the setters, and that's generally bad practice. So one way you could address that is let's get rid of this actual direct assignment to the variable. We'll get rid of the test, and instead we'll use the setters in the constructor. So we'll say set first name, first name. And you can do the same practice for the other fields that I'm not demonstrating, again, for the sake of time, but you get the idea. So we'll say set phone to phone. And what about the ID, right? So I like consistency, and it looks kind of bad doing the ID one way and everything else differently. So an easy way to address that is we can go down here and we can just make a setter for the ID, but we'll make it private. So it can only be called from within the class, which means it is still immutable in a practical way. And we'll just say this dot ID equals ID. We can copy the test down to it. Okay. Again, we have to declare that exception. And then we can go up here and we can use the setter. All right. Let's test our code to make sure everything still works correctly. It does. And let's go run all of the tests quickly to make sure we didn't introduce any bugs. And remember, this is called regression testing. We've made changes that were already tested, or excuse me, we had already tested the code, but now we've made changes, so we want to rerun all the tests to make sure we did not introduce any bugs. And we didn't. Everything looks good. So at this point, it's looking pretty good in the contact class, but I've got to make one point, and that is you're going to need to do a lot of these validations in your other code, right? So you've got 2 more assignments after this one. They will all have very similar validations, testing the length, testing not null, testing digits only, things of that nature. And you would have to copy all of these tests to all of those other classes, which, you know, is not necessarily bad in a trivial project like this, but, you know, we want to teach you good practice. We want to teach you the dry principle, which is don't repeat yourself. In other words, don't have duplicate code. So I suggest we create a new class, a utility class called validation. And we'll add that into a package also called validation. And in that validation class, we will create a new, or excuse me, in that package, we'll create the validation class. And we're going to make this class final, so it cannot be extended. And we're going to make the constructor private because it's a static utility class. We don't want instances of it floating around. And inside of it, we're going to create our reusable validation methods. And I'm going to just copy this code in here for the sake of time. But what I want you to notice is that I am using a custom exception. And that is an important thing you should note whenever you're writing code and you throw exceptions, intentionally throw exceptions, is good practice to create your own custom exceptions that extend either runtime exception or exception. So let's create a package. And we'll call it orgs new CS320 exceptions. And in this class, we're going to create in that package, we're going to create a validation exception class. And we want the superclass to be exception. And hit finish. And then exception is a serializable class. So in Java, that means you have to have this very special private static final long variable at the top. I won't take time to explain what that's for. Just know that you may be prompted to generate that. If you don't, your code will still run. So it's, neither here nor there. And then finally, we want to create at least one constructor. So let's go down to source, generate constructors from superclass. And we want to create only the one that it takes a string so we can pass in a custom error message. And that is our validation exception. Back to the validation class. Now we can import that to get rid of these ugly red lines. And so let's look over this quickly. We have validate not null. And what I'm doing is I'm accepting the value we want to ensure is not null. And then we're accepting a label so we know what field we're talking about when we throw the exception with a custom message. So we'll say, for example, if we were to say validate not null, pass in the ID value and the label ID, and if it were null, and then we could throw a new exception saying ID must not be null. Similarly, we have validate not blank. All we're doing is we're saying that the trimmed form of a string should have a length that is 1 or more. We're validating the length. In this case, we take a minimum length and a maximum length. and we just ensure that the value is between those two inclusively. So the error message would be, for example, first name must be at least 1 character and no greater than 10 characters in length. And then we're validating that the value of here is numeric. So we use that same regular expression I showed you earlier, and we could pass in the phone number and the label phone and have an error message, for example, that would read phone must only contain digits. So that is what this does. So back in our contact class, now we can go down to our setters, and we can replace these if statements with validation.validate not null. We'll use the first name's value and then the label first name. And we also want to validate that it's not blank. And we want to validate the length is between 1 and 10 characters. Now I'm going to copy this code here because we're going to reuse that, and we can get rid of the if statement now. We'll go down to phone. We will similarly replace that. Again, we're going to use the phone here, so we'll just place these values. And then we'll copy this down to the ID field. We'll replace the ID here. And then we want to go back to phone for a quick moment and add the validate numeric. And if everything worked according to plan, we can now go run our test, all of our tests again. And they pass. At this point, we want to add one more test, and that test is actually, we just want to clarify some of these tests or expand them just a little. We want to check that the correct error messages are being returned. So we'll drag the validation class over here so we have access to that. I'm going to add an additional value to our CSV source entries. And so we want to say, for example, ID must not be blank. We'll do the same thing for the first name. So first name must not be blank. And the phone. And now that we have that, we can accept that additional argument here. So we'll call it message. And we can say under is not null, we can say has message. And JUnit will confirm the message matches. So let's rerun all of our tests and see how that works. Everything worked except this one, and it looks like it's the first name did not quite match up. So looks like I have an additional space maybe. Let's try that. And then possibly the same thing with the phone. So yes, so phone has an additional space as well. There we go. And they all pass. Cool. Now we can do the same thing here. So we'll just copy the first name must not be blank. Put that there. First name must not be null. We'll put that there. And we'll check the length as well. So first name. So you see me, I'm copying this down to our other test method, and we'll do the same exact thing here. And then we'll rerun all of our tests, and those pass as well. So you can do the same thing. You'll need to test the setter for all of the other fields as well. You'll need to test all of the other fields in this failed creation test method. So that really just involves adding more entries to the CSV source. So that is everything with this. You can apply these same techniques and strategies to all the other assignments, your other 2 assignments. And you can apply these same techniques and strategies to finish this assignment. And I do suggest that you write some test methods for the validation class as well, right? You're going to be reusing this code all throughout this class, all throughout all 3 assignments. So it would be wise to test these as well. And there is one additional method I didn't show you here in this validation in this video. I will show you now, and it will be in the completed source code for you. It's validate is present or future, and you'll use that in either the second or third assignment where you have a date that can only be in the future. So there is, I did explain this on the course website, so just go check it out. But just for your awareness, I didn't show that in the video, but it is there. All right, with that, I'm going to close this video out. Please join me in the third video where I show you how to create and test the contact service. Thank you.